Now we'll look, though, at some of the other selections or choices that are commonly used for binding or bioconjugating proteins. And we have used the term previously in some other slides, amine groups. We've looked at some sulfhydryl groups. And so here's the accessible group. This is the name of the particular group. And this is the actual target structure of it. And then it reacts usually with something like one of these. And we have mentioned NHS esters before. So whereby you'd have this amine group on an antibody, you'd react with, say, a biotin or, say, a fluorescein NHS ester. And that's the way you would then get a biotin or a fluorescein attaching directly to that antibody. Some of these other groups, sulfhydryl groups, aren't freely available on an antibody, and so the antibody itself would have to be modified, usually through a reducing agent, to cleave the antibody to make these sulfhydryl groups available for subsequent reactivity with the maleimide group. And that maleimide indeed may then be conjugated with a biotin or a fluorescein itself, but the antibody itself would have to be modified. And the same thing with some of these other particular groups like aldehydes and azides are not present on antibodies, so the antibody itself would have to be modified in order to use a given linkage or reactivity or bioconjugate methodology. And so certainly this is just an abbreviated list of some of the many ways you can attach linkers to proteins, for example. And I'd say the most commonly used ones are the amines that's listed up here, as I mentioned, very prominent and available and accessible. That's another key word. You know, while something might be present on an antibody or indeed a target that you want to bioconjugate, the quick question is, you know, is it accessible, or do you have to modify it somehow to get access to that functional group so you can then put a linker on it? So since amines, primary amine groups, are readily accessible on things such as antibodies, they're usually the most popular method of targeting or conjugating antibodies. And then I'd say the next is probably the use of these sulfhydryl groups through some modification. We'll be talking a little bit about the linkage of an aldehyde and hydrazine, which is the basis of the SoluLINK chemistry, a little later on. All right, so some of you might be thinking, hey, this is great, Craig. So, you know, I'm getting pretty interested here in bioconjugation. I've always wanted to know about it. So what are some of the considerations if I want to, you know, launch into a project? Well, you want to step back a little bit and have a consideration about, well, what is the actual intended application and how is it going to be performed? Is this going to be performed in solution, for example, or indeed is it going to be a bioconjugation on a hard surface or a matrice, a bead, such as we mentioned before, an agarose bead? And what is that biomolecule that you're going to be conjugating? And indeed, the 2 points there, what is the intended application and what is the biomolecule, will probably lead you then into the choice of chemistry. You know, what is available for conjugating or accessible, what reactive group or functional groups, I should say, are available on that biomolecule. And once you've sort of looked at those options, a further one would be a spacer arm selection. If you can remember back to the diagram I showed earlier on of that biotin NHS ester, we had that spacer arm that essentially joins the reactive group with, you know, the biotin of that example. And the spacer arm can vary in a number of different ways. I mentioned it comes in different flavors. And what I meant by that is it comes in different lengths and different composition, which may affect things such as solubility. And also, there is another factor there that could be important, and we'll touch on this a little later on, is whether or not you can actually cleave it. And what that means is by splitting it using something such as a reducing agent, or indeed, as we'll see later on, a UV light, for example. And that may add functionality to that bioconjugate. Certainly solubility and stability. You know, are you working with a labile molecule that might not be soluble in aqueous phases, or does it precipitate out in organic solvents like a DMF or DMSO, for example? And also then stability in solution prior to the conjugation, and also stability after conjugation. Does it have a very short half-life? Does it, as I mentioned just then, crash out of solution? Can you actually use that in a functional way? And then consideration, once you've done the bioconjugation, think about what you're going to do with it for subsequent, detection or capture, visualization methodologies, isolation, and things like that. So you can see this is, again, it's just an abbreviated list of considerations when you're starting to get into bioconjugation. It can get complicated quickly. And indeed, the title of this particular webinar is Introduction to Bioconjugation. And so you could certainly go off right now and we could wave you off and say good luck with using separate linkers like the BIOT and NHS ESTA. But I think you'll find pretty quickly that there are a number of other considerations that you'd have to take under consideration, such as, pH, buffers, salts, things like that. How are you going to purify it as well? That may not be readily available. It may be expensive to do or a little complicated. So we're going to have a look at some of the kit formats coming up here that I think would be a great way to introduce yourself, or indeed a lab member or your lab, to bioconjugation. But let's just take a step back and have a look at some of the applications where bioconjugation can come in. And it doesn't sort of happen in a vacuum. No one sort of wakes up and goes, hey, I'm going to conjugate an antibody to fluorescein today. Usually, and I'll walk you through this slide, usually it starts with a research project. Over here on the left-hand side, you're thinking, you know what, we've got whatever it might be. You're looking at something you want to capture or indeed isolate a given protein. You want to detect it or visualize it. Maybe you're trying to upregulate something and you want to quantify it. I've got the word there, perturbation. Maybe you want to interfere with a cellular cascade or pathway, and you want to inhibit something or stop it and see what happens. And that's just an abbreviated list then again. And you're thinking, well, how am I going to probe this? How am I going to, undertake this particular research project? What you do then is think of various investigative sort of techniques in doing that, whether it be using flow cytometry, a fluorescently conjugated antibody, some cell or tissue-based staining, microscopy such as electron microscopy, for example, or immunoassays such as lateral flow, protein or Western blotting. Maybe you'd quantify something with an ELISA. Surface plasmon resonance is certainly gaining popularity out there. Maybe you want more defined drug delivery, and I'll show you an example of that coming up. Or indeed, maybe you're working with an omics platform. And what I mean by that is whether it's proteomics or a genomics platform. And indeed, when thinking about that, and indeed all of these investigative sort of techniques do incorporate the use of bioconjugates. And it might be that, your favorite vendor, for example, whoever that is, doesn't have all of the repertoire of conjugates, that would help you probe or generate the results you want in a given research project. Maybe you could take it further by having, an antibody conjugated to a novel enzyme or a fluorophore, or you need to plate it somewhere to capture or isolate material. And the same thing for some of these other particular biomolecules as well. Hopefully the idea of this slide is to start getting the juices running in your mind and thinking, okay, how can I push my research project further? Or what if I could quantify, perturb or whatever it might be, a given cascade or signaling pathway in my study? Could you push that particular research further and probe new areas? And this is where the bioconjugate tools come in. Okay, so we've just gone over what is bioconjugation, some of the common examples and the nomenclature. As I mentioned, we just dipped our toe a bit in some of the organic chemistry. And Looking at some of the applications here, hopefully it's starting to get you a little interested. Let me show you a couple of case studies where people are using bioconjugation, and while I'll say where bioconjugation is vitally important in generating the results they want.